Good evening, all. In today's session, let us see how the system properties are defined. You can see it on the screen. I have shared it. Some 6 properties I have listed. We have to see how each property of this system is defined. All these properties, which you can see it, they are all familiar words to you. If you see, okay, let me start with the linearity. Linear in the term, this term is familiar to you in the sense linear. I think linear components, linear graph. So linear is a very familiar word to you. Linear indicates what? The principle of superposition should be followed. That is called a linear. Okay. Then time invariance. Time invariance. Invariance means which should not vary. So time invariance means the time should not vary. And memory. So memory, you have studied circuits, digital circuits, probably DSD you might have studied. So you know what is a combinational circuit, what is a sequential circuit, how they differ from each other. So it is the main thing which they differ in is, one is memory component, the other one is the clock, right? So memory. This probably causality is a new term to you that I'll define. Stability. I hope you have studied control system. So in control system, you might have come across stability. How you say any control system, whether it is a stable system or unstable, depending on, I guess, poles and zeros, Bode plots, poles and zeros, you determine the stability of the system. And invertible, invertibility. Invert means what? Reciprocate. So all these terms are very known terms to you. So hopefully it might not be a problem for you to understand these properties. Let us start with the first property, that is linearity. As I told you, linear indicates it should obey principle of superposition. What is the superposition? Suppose that you have a system, okay, with some h operator, and assume that you have the input x of t. Okay, I am considering a continuous time signal and continuous time system, and suppose you are getting y of t as the output. Now, according to the linearity, what it says, if your input is a combination of many inputs, assume if it is having say 3 inputs, that too it is a combination, it is the sum of 3 inputs, then according to the linearity, your output will also be sum of these individual components. Okay, so if x is the input, y is the output for any system with the operator h, then according to the linearity, what it says, your input signals, if they are added sum of many signals, then your output will also be the added sum for those corresponding signals. It means अगर आपका input x1 है तो output y1 रहेगा, input x2 है तो corresponding output y2 रहेगा, and अगर input x3 है तो corresponding output y3 रहेगा. So corresponding is very important here. So y1 applies to x1, y2 is the output for x2, y3 is the output for x3. So likewise, according to the linearity, it should apply the principle of superposition. If input is the sum of inputs, output will also be the sum of the outputs. That's what I have explained here. A system is said to be linear if it satisfies the principle of superposition. If the input consists of weighted sum of many signals, weighted sum means it can be simply either 1, 2, 3 like that, or weighted, it can have some coefficients, a x plus b x2 plus c x3 like that. So these weights are some general values. So weighted sum, it is the weighted sum of many signals. Then the output is also the weighted sum of the responses. A response is a synonym we use for output. Okay, it means response output, both are same. It is the output for the system to each of these signals. This is important. That's just now I have explained you the word corresponding. Okay, that's what it means. To each of those signals. It means अगर आपका input x1 है तो corresponding output y1 है. Okay, x2 है input तो corresponding output y2 रहेगा. So अगर आपका input sum of these x1, x2, x3 है, the output भी आपका sum of y1, y2, y3 रहेगा. Okay. Now, how can I represent this linearity in terms of equations? Suppose, let me just take only two simple inputs, only two values. I can extend it to many, no problem. For my simplicity, let me take only two. Suppose I have x1 as the input and x1 of t. Okay, अगर मैं discrete time ले रही हूँ तो it will be x1 of n. For a continuous time system, we have the output y1. Input x1 of t है and output is y1 of t. Similarly, if I have x2 of t input and the corresponding output is y2 of t, if this is the case, if this I have, then if the system gives the output y1 plus y2 for the input x1 plus x2, अगर input आपका sum रहेगा x1 plus x2, output आपका y1 plus y2 रहेगा. Okay, then the system is said to be linear. Now, how can I write this in terms of equation? If x1, this indicates corresponds to the output y1, x2 of t gives the output y2 of t, then the system is linear if I'm taking the weighted sum. Okay, I don't know what are these. It may be 1, 1 or it may be 1, 2, 3, whatever. A, B are some numbers. So if it is a weighted sum of x1 and x2, then the output is the weighted sum of y1 and y2. This is how we mathematically represent linearity. Okay, अगर x1 आपका input है and y1 output है, similarly अगर आपका x2 input है and y2 output hai, then when we say that the system is linear, this should be satisfied. Ax1 plus bx2 should be equal to ay1 plus by2. So suppose अगर हम problem solve कर रहे हैं, we should try to check this. आपको अगर individual x1 and x2 है आपके पास, तो if you add them, you should get y1 and y2. So we should basically in the problems we are looking for this equation. Okay. Similarly, you can see it on the screen. I have written a similar equation for linearity for discrete time. Simply t is replaced with n. Fine. I hope you understood about the linearity. Then let me just go to the second property. You can say it. Second one is time invariance. So invariance means which should not vary. What should not vary? It is given here. Time. Time should not vary. So according to the time invariance, a time invariant system is one for which a time shift of the input signal causes a corresponding time shift in the output signal. Okay, what does this mean? Suppose मैं आपको एक practical example देती हूँ time invariance के लिए. You attend your 3 hours examination, okay, final semester examination, which starts from 2 to 5. So totally 3 hour duration exam you have. Suppose due to some issues related to the question paper arrival, some 15 minutes delay will occur, say. Okay, so your exam will start at 2:15. So ideally, what should happen? What should be the end time? It should be 5:15. No doubt there is a delay. Time change हो गया. Original time 2 था, slotted time, but scheduled time is 2. But it started at 2:15. There is a time variation. Okay, there is a time shift. There is a time shift of 15 minutes. Originally it was 2, but it started a bit late, 15 minutes late. So it is 2:15. Okay, so it should have been ended at 5 ideally, but because of this delay, what happened? Your exam ended at 5:15. So no doubt original time 2 to 5. So it is not equal to this. It is 2:15 to 5:15. There is a change. Okay, these two are not matching. However, check the duration. Both duration is 3 hours only. So this is called time invariance. Even though the times are not matching, but the total duration is same. Why it is same? Because the exam which was supposed to be started at 2, it started at 2:15. Hence, the exam which should end at 5, it will now end at 5:15. So there is a time shift of 15 minutes in the input starting time. So obviously, at the end, for the end time, there is a corresponding time shift in the output. So this is called time invariance. I hope you understood the example. Okay, there is a time shift in the input signal, input time. It causes a corresponding shift in the output. That's what I just now explained you with an example. And this shift, it can be advanced or delayed. So, suppose आपका एग्जाम 3 to say 6 होना है, क्वेश्चन पेपर जल्दी आने की वजह से अगर आपका एग्जाम 2:30 को स्टार्ट हो गया, सी हाफ एन आवर बिफोर इफ इट स्टार्ट्स, देन ideally it should end before half an hour. Okay, so this is time advancement. Okay, jaldi start ho gaya. Delay means 2:15 to 5:15. Okay, now just now we have seen the definition of time invariance. Now we have to see how we can write the equation for this. Okay, let us consider a continuous time system. Suppose आपका output y of t आएगा अगर input आपका x of t है. Okay, if this is the case, then the system is said to be time invariant if the input x of t minus t naught. What this indicates? T minus t naught indicates shift of the time, and we don't know what is the sign of t naught. We have already seen in module 1, the signals part, time shifting property. So depending on this sign, whether you will get a left shift or the right shift. Left shift indicates advanced, right shift indicates delayed. So the sign minus or plus will decide this advanced or delayed shift. Okay, so if this is the case, if we have the input x of t and output as y of t, then the system is said to be time invariant if the input x of t minus t naught shift in the input, it gives the output shift in the y, right? So there is a shift of t naught in input, so there is a shift of t naught in the output. So how can we write this mathematically? You can see it. If x is the input, corresponding output is y of t, then the system is said to be time invariant if there is a shift in the input signal by t naught, then your output will also get shifted by t naught. Okay. Similarly, I have written the equation for discrete time. See, t is replaced with n. That's it. If I have an input signal x of n, output is y of n. Then if I shift the input by n naught times, then even your output will get shifted by n naught times. This is how I can write the time invariance property mathematically. I hope you understood these two properties. Any doubt in this, you can ask me. Yep. What happened? Okay, is there any chit chat going on? Let's go to the third property, that is memory. The third property is memory. So it's a very familiar term to you. You have studied this in logic circuits, combinational logic and sequential logic. Combinational logics, the basic gates which you have studied, they are not having any memory. Okay, no past values, no storage values. However, when you go for sequential circuits, the flip-flops, then what, the counters, all those, they are having memory with the clock pulse. So you have the past values there. So again here memory term, the definition of this memory is again same. You should have certain past value, then we call it a system has a memory. अगर आपके पास past values नहीं है, सिर्फ present values हैं, तो हम memory less बोलेंगे system को. So how we can define memory for a continuous time system? It is referred to as memory less. Okay, memory less if the output y of t at every value of time, it depends only on the input x of t at the same value. Means I'm talking about only the present value. अगर आपका input x of t है, तो आपका output सिर्फ y of t रहेगा. Only present value of the time. If I want say x of 5, means at time instant 5 अगर मुझे input signal define करना है, आउटपुट भी आपका x of 5 पर भी देखना है, नो अदर वैल्यूज. ओके, वी कॉल दिस अ मेमोरी लेस सिस्टम. ओके, similarly I have defined this memory property for a discrete time system. It is referred to as a memory less system. It is not having memory if the output y of n at every value of n time depends on the input at the same value. Means सिर्फ हम present की बात कर रहे हैं, present value of the time. Okay, this is called memory less I'm talking about. You can even tell in a converse way, the system has a memory बोल के भी आप define कर सकते हो. That how you define if the system has something like this, x of n minus 3. Some delayed terms are there, it means system has a memory. Delay कब होता है? जब present value रह के उसके बाद थोड़ा रुक के then next step आता है, then we call it a delay, right? There is a time gap. So gap कब आता है? past value है तभी gap रहेगा. So अगर आपके equation system में question में अगर ऐसे shifts आएंगे, then you call it as the system is having memory. अगर ऐसे shifts नहीं हैं given system में, question में, then you can say it, the system is not having any memory, it is memory less. And one more thing I forgot to tell you right here, it is also called static and dynamic property. Okay, static means memory less, dynamic means it is having memory. Okay, sometimes instead of memory, the question may be check whether the given question or given system is having is static or dynamic. So don't tell that we have not studied this property. It is just a synonym we use for memory. Okay, this is one alternative name used for this memory property. Then let's go for the causality property. It is a new term to you. Don't pronounce it as a casual. Okay, it is causal, C-A-U, causality. So how you define causality? A continuous time system, it is said to be causal if the present value of the output, it depends on either past and or. तो अगर या तो past है या तो present है, we should not have any future values. Means what? अगर आपके इक्वेशन में जो भी क्वेश्चन देते हैं उसमें अगर आपको ऐसा टर्म मिला है तो देयर इज अ शिफ्ट, देयर इज अ डिले, तो पास्ट वैल्यू आ गया. अगर क्वेश्चन में ऐसा कुछ है एडवांस, ओके, फ्यूचरिस्टिक वैल्यू, प्लस इंडिकेट्स फ्यूचरिस्टिक वैल्यू, सो दिस इज नॉट कॉजलिटी. ओनली द पास्ट इज अलाउड और इवन द प्रेजेंट इज ऑल्सो अलाउड. एक्स ऑफ एन, वाई ऑफ एन. अगर आपका इनपुट करंटली x of n है, सो करंट आउटपुट y of n रहेगा. आई एम टॉकिंग अबाउट डिस्क्रीट. सिमिलरली यू कैन टेल फॉर कंटिन्यूअस ऑल्सो. अगर आपका इनपुट x of t है, आपका y आउटपुट y of t रहेगा. अगर इनपुट डिलेड वर्जन है, सो पास्ट, राइट, मेमोरी है, देन ऑल्सो इट इज कॉल्ड कॉजल. बट दिस इज नॉट अलाउड. Futuristic value, this is not allowed. Okay, so I hope you understood causality property. Then let's go for stability. Stability is again a familiar term to you. In control system, you might have studied about this stability. More, precisely, stability can be got by poles and zeros location. But however, here still you are in the start of the, the basics. So let's not get into that. When we study Z transforms, we will be dealing the stability property in depth. So superficially, let us define stability. A system is said to be bounded input, bounded output, stable, if and only if every bounded input results in bounded output. So what do you mean by this? See, for any given signal or a system, अगर आपका input signal limited है, it is not infinite, assume करो ये कुछ 100 है या 200 है, or if you calculate the value, say it has some 5 value, 10 value, some number which is countable. अगर ऐसा है तो अगर आपका आउटपुट भी काउंटेबल आता है, बाउंडेड आउटपुट आता है, फॉर अ बाउंडेड इनपुट, इफ यू गेट अ बाउंडेड आउटपुट, दैट्स व्हाई इट इज कॉल्ड BIBO स्टेबल, बाउंडेड इनपुट, बाउंडेड आउटपुट, then we call this stable. This is very important. You can see it here. For a continuous time system, what I have done, I have taken the input x of t, some number bx, and the output y of t, some number by. Suffixes indicates whether it is input or output. Okay. And what are these bx, by? They are some finite numbers. Okay. इसका मतलब क्या है? Both x and y, your signals, they are limited. So when both are bounded, then we call it a stable system. This is the definition for stability. And similarly, I can define stability for discrete as well. If you have an input x of n, whose value is certain limited, finite number, which is less than infinity, then you will get the output, which is also a bounded value, that the finite value is less than infinity, obviously. Okay. So if this condition gets satisfies, then we call it the stable system. Then we call such a system as stable system. Okay. Just remember that bounded input, bounded output. अगर input आपका limited है, output भी limited ही आना चाहिए. The last property, invertibility. So again, invertible, reciprocal, you can, the alternative, you can tell me the name. Invertible system. Let me just give you an example. If I have, just a second. Okay. Okay. What is the differentiation of x square? The differentiation of x square is 2x, right? Now, okay, I'll just explain this later. First, let me define what is invertibility. A system is said to be invertible if the input of the system can be recovered back from the system output. Say, ये आपका एक system है, okay? System है, input आपका x of t है, okay? And ये output है. That's what I said. यहाँ पर अब मैं d by dx of x square. If this operator is differentiation operator, then आपका input आपका x square है. So differentiation of x square will be 2x, right? Now, suppose I take one more system here, cascaded system. Okay, I don't know what is that system. Upon application of this system on this 2x, I should get this input back, x square back. So ऐसा कोई system यहाँ पर जब मैं connect करती हूँ, 2x जो number है, आपका signal है, ये जब operator से वो apply होगा, you will get this x square back. We call such a system as invertible system. Okay. One example I can tell you. अगर आपका ये एक सिस्टम है, ये इनपुट है, ये सिस्टम अगर डिफरेंशिएशन है डी बाई डी टी, तो ये आपका आउटपुट आएगा. नाउ what is the inverse of differentiation? You know, the converse operation, what we call, we have integration as the converse operation. So if the first system is differentiation, then if I take one more system in cascade in series, which is the converse operation, integration, I can get the original signal back. Then I call the system 1 as the invertible system. So system 1 is invertible and system 2 is called inverse system. Okay, this is invertible, this is inverse. Inverse, if this is the differentiation, so integration is the inverse of the differentiation. Okay, one more of such example is what? I think multiplication and division. You can even take that one example. Okay, so we have studied 6 different properties. We have seen today how they are defined. We started with, let me just summarize. We started with linearity. We have seen that the principle of superposition should be applied here in the linearity. We have seen how the linearity is defined in the form of equation. This is important for our problems. Okay, we have to check this equation. Similarly, for time invariance, there should be a shift in the input, corresponding shift in the output. So we have seen this. So this has to be checked. अगर इनपुट शिफ्ट हो रहा है तो आउटपुट भी शिफ्ट होगा या नहीं होगा, दैट वी नीड टू चेक. देन थर्ड प्रॉपर्टी, मेमोरी. Memory is also called static and dynamic systems. So memory and memory less. So memory is based on what? The past values. अगर past value है system में तो memory है. Past नहीं है, सिर्फ present, x of t, y of t, x of n, y of n. Then we call that system as a memory less system. Then the next property is causality. For causality, two different values are okay, either the present value or the past value, but not the futuristic value. So +1, the advanced version we don't require. For stability, bounded input, bounded output should be satisfied. That is, अगर input आपका limited value है, which is less than infinity, output भी आपका bounded value आएगा, which is less than infinity. Then the last one, invertibility. Suppose we have a cascade system wherein if you apply x of t as the input, you will get y of t as the output for system 1. Suppose if I connect one more system here in series such that the original signal can be brought back, we call system 1 as invertible system and system 2 is the inverse of system 1. One good example is differentiation and integration. I hope you understood today's properties definitions. If you understand these properties definitions, then only it is possible for you to solve the problems. So if you have any doubt, please let me know. I'll explain it one more time. Still we have the time. Any doubts?
All will be so this particular location person place. क्योंकि ताजमहल के जैसा दूसरा same they model.
Fine. So if you have any doubts, you can ask me. Else I'll end the session. We'll continue with the problems on these properties in the next session.